All right, guys, the first thing I want to do is go over the terminology I'm going to be using a lot this year. We're going to start with 1.1.1 notes. The first one right here is the module or unit number. The second one is the topic or chapter number. And the third one is the lesson or section number. So for instance, this is the first lesson. So 1.1.1 is what we're doing. But tomorrow, or the next time I see you, might be Unit 1, Chapter 1, Section 2. At the end of this chapter, we're going to have a unit test. So you might see 1.1 test coming up. What that means is Unit 1, Chapter 1 test. The other thing is up here, you're going to see me talking about page numbers all the time. The M1 means Module 1. So we're talking about the first unit. So I'm just probably going to keep saying page 7, and since we're on module 1, M1 is understood. So when I say page 7 or page 13, I probably won't be saying M1. All right, today's lesson, we're going to be learning a lot about graphs. We're going to focus on independent and dependent variables to make sure this is all fresh on your brain before we get into some other stuff in this unit. We're starting with a warm-up here, and it says Emma bought a new video game. The graph describes the number of hours Emma spent playing the game over a period of 7 days. What we want to do is we want to label the axes. Now, the x-axis at the bottom goes 1 through 7, and the y-axis on the side goes 1 through 7. The points are kind of sporadic. The first point right here goes 1, 2, 2, 3, 3, 4. So this point goes 2, 3, 4, and then back down to 3, and stays 3, and then back down to 2. But if you go this side, it goes 1, 2, 3, 4, 5, 6, and 7. So what that tells me, if she's playing video games for 7 days, these numbers represent the days. Now, if those are the days, that means that for the first day, she spent 2 hours playing video games. The second day, she spent 3 hours, and my God, that is a lot of time playing video games. So the y-axis, those numbers are representing the hours. And again, question number 2 at the bottom, the highest point on this graph would be this point right here, and it means on the third day, she played 4 hours of video games. All right, I'm on page 8 right now, and we are going to be learning the independent and dependent quantities. Now, again, this is the number 1 focus of today's lesson, so this is a must-know for today. And we're going to use this example right here where it says, if you ever planned a party, you may have purchased ice, gone grocery shopping, select music, made food, or even cleaned in preparation. Many times, these tasks depend on another task being done first. For instance, you wouldn't make food before grocery shopping, now would you? Now it says consider the 2 quantities that are being changed in each relationship, and they give us 5 examples here. At the bottom it says we want to circle the independent quantity and underline the dependent. And I have highlighted over on the left, when one quantity depends on another in a problem situation, it is said to be the dependent. Obviously it depends on the other one, it is the dependent. The quantity that depends upon is called the independent. So theoretically, whichever one should come first is going to be our independent. Whatever comes second is going to be our dependent. For instance, if you're going to buy food for a party, you need to know the number of people who are coming. You need to know the number first, then you buy the food. Okay, so we're going to walk through these 5 examples real quick, and we are going to circle the independent and underline the dependent. All right, so number 1, the number of movie tickets that you're going to purchase and the total cost of buying all those tickets. Now, which one do we need to know first? We need to know the number of movie tickets, and what comes second would be the total cost. Number 2, the number of eggs used and the number of cakes baked. Which one would come first? Well, I would need to know how many cakes am I going to bake. Am I baking it for myself? Am I baking it for an entire class? So I need to know the number of cakes first, and that tells me how many eggs I need to use. Number 3, the number of students in attendance at a school and the number of lunches served. So which one do we need to know first? Are we going to cook 50 lunches, 1,000 lunches? We don't know. We need to know the number of students first. So that is our independent, and the number of lunches would come second, so that is our dependent. Number 4, the number of hours driven and the number of miles to a vacation destination. So which one do we need to know first? Do we need to know where we're going, or do we need to know how long it takes to get there? So I always want to know where I'm going, because that determines how long I need to drive. So the number of miles to my vacation destination is what I need to know first, and the number of hours driven would come second. And the last one, number 5, the minutes. Swimming pool is filled with water and the number of gallons of water in the swimming pool. So imagine the pool's empty, you're filling it up. We want to know at what time is there however many amount of gallons in there. So what do we need to know first? Are we talking about the beginning when we're just filling it up, or are we talking at the end when it's almost full? So the first thing we need to know is the minutes. So that is our independent. And then what comes second is, once you know how many minutes, then you can figure out how many gallons. So gallons is your dependent. All right, now normally when we do these videos, I will skip around a lot and I do the bare minimum with you guys because it's hard to do a lot of this stuff over a video. I try not to make it too long. But for today, I am going to walk you through a little bit slower, so if this video is longer, I apologize. Now we're going to start talking about connecting different scenarios and their graphs. It says, while a person can describe monthly costs to operate a business or talk about marathon pace a runner ran to break a world record, graphs on a coordinate plane enable people to see data. Graphs relay information about data in a visual way. You can use lines or smooth curves, and that's important, lines or smooth curves, to represent relationships between points on a graph. In some problem situations, all the points on the line will make sense. In others, not all the points will make sense. So when you model a relationship with a line or a curve, it is up to you to consider the situation and interpret the meaning of the data values show. All right, so what we're going to do is we're going to kind of list the independent and dependent qualities for these scenarios. We're going to start with the daredevil here. Grayson completes a dive off a cliff 75 feet above the river. It takes him only 1.5 seconds to hit the water and then another half second to descend 10 feet into the river. All right. So if I was picturing a graph in my head, not really looking for a graph because I know they have graphs listed, I want you to try to picture this in your head. I have Grayson who's standing up on a 75-foot cliff. So in my head, I picture a graph with Grayson standing right here, and that would be 75 feet. Now, if in my head, if I'm picturing this as 75 feet, that means this axis is feet or height. Then I picture him, he's jumping, he's floating in the air, and he first starts off, if you ever jumped off a cliff, I hope you haven't, you can tell you always start off really slow going down, and then you speed up really quickly. And then at this point right here, you splash and hit the water. And it said that he hit the water after 1.5 seconds. So this would be 1.5, and again, 1.5 seconds. So this axis represents seconds or time. And then he goes into the water. Now, once you hit the water, you're not going at the same speed, so this was going to slow down a little bit. And after 0.5 seconds, he's 10 feet under. Okay? So this is the graph I would be picturing in my head. Now, because I pictured it this way, this makes the independent and dependent quantities very easy for me. The independent is your x-axis, and we said seconds or time. So I'm going to write time. The dependent is your y-axis, and we said height or feet. All right, the second scenario, something's fishy. Candace is a building manager for the Crowley Enterprise office building. One of her responsibilities is cleaning the office building's 200-gallon aquarium. For cleaning, she must remove the fish from the aquarium and drain the water. The water drains at a constant rate. That is a huge key term right there, of 10 gallons per minute. So in my head, she's cleaning this aquarium, so it's got to be full. So I picture full with 200 gallons. So in my head, I'm picturing a graph that would start right here at 200 gallons. Now again, I just said gallons, so that means this axis represents gallons of water. So I have 200 right there. Now it's draining at a constant rate of 10 gallons per minute. So that means after 1 minute, there's 190. After 2 minutes, there's 180. And this keeps going, 170, 160. So I'm picturing it going down at a constant rate, which would make a